Hi everybody, this is Mr. Folly again, and welcome back. I greatly appreciate you sticking through here and for being patient as I get my pen to work and wonder why my podcast crashed in a time or two. Here we go. So A to F is elementary, that means one step. A plus B to C is elementary. But if I'm trying to make G, right, in order to make G, I have A plus B makes C plus D. And then take D plus E makes F. Well, that's funny. And then F plus C makes G, then the overall reaction will be A plus B plus E yields G. Notice how these are three steps. This is not elementary. Isn't that interesting? So let's hope we can get back to this. So these, whoa. Okay, so C and D are intermediates. Notice how they would cancel out. Oop, I said C and D are intermediates. C actually is an intermediate, so is F. So C cancels, D cancels, F cancels. Okay? So catalysts speed up a reaction but are not used up. So if I cut a loaf of bread with a knife and nothing else, so imagine you're out in space and you got yourself a knife, because everybody does, and you want to cut a loaf of bread, and you try and cut it in the air, and you're moving your arms. It's real hard to do, especially with an arm that long. And if you had a table, you could speed it up, and it would go a lot faster. So it's not used up. The table isn't used up as you go chop, 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 chop. It still works. So looking at this, you see how B is a reactant, and then it's a product. So these would cancel out. AB would cancel out. And notice A cancels out. Whoops, that's a boo-boo right there, isn't it? So, hey, I think you found yourself a mistake in the podcast. So if I said, let's throw this in here, R plus A. So my overall reaction would be R yields D. And we pointed out that my catalyst would be B as in boy. B is a reactant and a product. That means it is a catalyst. It cancels 2, but is needed to make D. An inhibitor does the same thing, but it slows down a reaction. So it is used up and then reformed. Rate determining steps are the slowest step. So if you make a cake, you got to mix some batter. You've got to bake it. You've got to frost it. And the thing that takes the longest is baking a cake. It takes 20 minutes or so to bake a cake. It takes 2 minutes to mix and 30 seconds to frost. So if I had to make 1,000,000 cakes, if I found a way to mix the batter faster, that doesn't do me any good. But if I had to make 1,000,000 cakes, it basically takes 1,000,000 times 20. If I found a way to bake a cake in 20 minutes, I saved a lot of time. If I found a way to mix a cake in 1 minute, I saved 1 minute, not a whole bunch of times. So for 1,000,000 cakes. What step would a catalyst affect? The slowest step. Lamb cape. Collision theory. In order for a reaction to be successful, particles must collide. Bam! With enough energy. Bam! In the right orientation. Ouch. Like kissing Aunt Millie. Or instead of Aunt Millie, like kissing, I don't know, somebody's grandma. I don't know who has the guttural grandma thing. But in order to kiss somebody, oh boy, is this bad. I'll put a smile on your face. You've got little nose things, so you've got to have the right orientation. Hopefully eyes and a mouth. Got to have the right orientation because the nose bump is bad. So you got to collide. You got to give them with enough energy. If it's too hard, bam, you're breaking some teeth or hooking up some braces. And the right orientation, if you have the nose-to-nose smash, that's bad. So all reactions need a collision with enough energy in the right orientation. So looking at this, if I'm trying to make two NOs and a Br2, this orientation would produce a good result. This orientation would produce a good result. This orientation could never make those. And realize things collide at different than 90-degree angles. Success rate is low. Imagine putting pen caps and pens in a box and look and see how many pen caps fit on the pen cap. So these are pen caps. I hope you can hear it. You probably can't. How many pen caps? And shake it, shake it, shake it, shake it, shake it. And how many pens will eventually have their pen cap on them? That's not even a terrible pen. In chemistry, 1 out of every 12, so every 10 to the 12th is possible. That is a 1 out of a trillion. How can I affect the rate of reaction? Surface area. If I have a greater surface area, I can have more collisions. More collisions means more successful collisions. So that means a faster rate. Temperature. Particles move faster, so you have more collisions. So not only do you have more collisions, another reason why is they collide with more energy, which is more important. And we'll get to this in class. More energy is more important. Catalyst lowers energy required. Dink. Review. Hey, that's nice. Kinetics look at rate. Sorry, this is split in half, and I've got to get out of here quickly. Reactions occur in steps, mostly. Slowest step determines the rate. Intermediates are formed and then used up. Catalysts are reactants to products. Collision theory, bang up job. Toodles. Thanks for watching.